Something strange has been discovered inside 3I Atlas. It is not just a minor irregularity. It is something so fundamentally out of place that the James Webb Space Telescope, the most powerful observatory humanity has ever constructed, had to read the numbers back twice before the scientific community would accept them. What JWST found was deuterium, and not just a little. Massive record-breaking quantities of it, pouring off the surface of 3I Atlas. Now, if you don't know what deuterium is, here is why it matters more than almost anything else in this context. Deuterium is a form of hydrogen. Specifically, it is heavy hydrogen, an atom with one extra neutron packed into its nucleus. That single extra neutron makes it fundamentally different from ordinary hydrogen. And that difference is exactly why we use it here on Earth as the primary fuel source for nuclear fusion reactors. Deuterium and tritium together form the most efficient fusion fuel combination known to science. They ignite at the lowest temperature, they release the highest energy, and they are the foundation of every serious fusion energy program currently running on this planet. When scientists talk about the future of clean, limitless energy, they are talking about deuterium. Using spectroscopic data from the Webb telescope, scientists analysed two molecules being shed by 3I Atlas and found one deuterium atom for every 100 hydrogen atoms in water, and one deuterium atom for every 30 hydrogen atoms in methane. To understand why those numbers are extraordinary, you need a baseline. The primordial abundance generated in the first 20 minutes after the Big Bang was one deuterium atom per 40,000 hydrogen atoms, similar to what is found in the Sun or Jupiter today. Earth's oceans sit at around 1 in every 6,500, already elevated compared to the cosmic baseline, already unusual. 3I Atlas sits at 1 in 30. The deuterium abundance around 3I Atlas is 1,000 times larger than the average cosmic value. Not slightly elevated, not a statistical outlier nudging the edge of a distribution curve, 1,000 times the cosmic average. And Avi Loeb, Harvard astrophysicist, former chair of Harvard's astronomy department and head of the Galileo project, looked at those numbers and said it plainly on the record. Deuterium and tritium are the best fuel for nuclear fusion, and what we see around 3I Atlas is an abundance of deuterium 1,000 times larger than the average cosmic value. And then he asked the question nobody wanted asked. Could this be a technological signature? Could what we are seeing be the exhaust of an alien engine? Not the outgassing of ice, not frozen material sublimating under solar heat. The exhaust of something running, something powered, something burning nuclear fuel across billions of years of interstellar travel. That is a Harvard scientist asking that question out loud under his own name, and the scientific establishment has not produced a clean natural explanation for those numbers since. But the deuterium is only one piece of this, because Loeb did not stop at one anomaly. He catalogued them, organized them by statistical likelihood, published them, and kept updating the list as new data came in. By December 2025, the number of flagged anomalies had reached 15. 15 separate independent measurements that each resist natural explanation. And when you go through them one by one, the picture that forms is not of a strange comet. It is of something that does not belong in any natural category we have. Start with the sunward jet. In the summer and again in November of 2025, 3I Atlas grew a concentrated jet of material pointing directly at the sun. Every comet ever recorded in human history has a tail pointing away from the sun without exception. This is a direct physical consequence of solar wind pushing material off a comet's surface and blowing it behind it. It is one of the most consistent and predictable behaviors in all of planetary science. 3I Atlas did the opposite. It pushed a beam straight into the solar wind. If this were a spacecraft traveling at 60 kilometers per second through interstellar space, that sunward beam would make perfect engineering sense. A forward shield, deflecting debris and micrometeorites before they could strike the hull. At that velocity, even a grain of sand hits with the force of an explosive. But this is supposed to be a comet, and comets do not do this. Then there is the chemical signature. The gas cloud surrounding 3I Atlas contains far more nickel than iron, a ratio matching industrially produced nickel alloys, not natural space rock. In the natural universe, nickel and iron form together through the same stellar processes and appear in predictable proportion. The ratio coming off 3i Atlas breaks that proportion completely. The specific fingerprint it produces is the kind that results when a civilization processes raw material, removes what it does not need, concentrates what it does, and builds something from what remains. Loeb put the probability of this chemical profile appearing naturally at below 1%. Then there is the size. 3i Atlas is estimated at perhaps several kilometers across, but place it next to the two previous confirmed interstellar visitors, and the comparison stops making intuitive sense. Its nucleus is roughly 1,000,000 times more massive than 1i Oumuamua and 1,000 times more massive than 2i Borisov, and it is moving faster than both simultaneously. The combined probability of a natural object being that much larger and that much faster is less than 0.1%. If it is natural, it is the most statistically improbable natural object ever recorded in the history of astronomy, not close. And then there is the age. This object formed 10 to 12 billion years ago. Our Sun is 4.6 billion years old. Every planet, every moon, every comet we have ever studied came into existence billions of years after this thing already existed, when the gas cloud that would become our solar system was still drifting unformed through the galaxy. This object was already ancient. Whatever made it did so in the early universe, when the first generation of stars were just beginning to form and die. Now put the flight path on top of all of this. Its arrival was timed so precisely that it passed within tens of millions of kilometers of Mars, Venus, and Jupiter in one clean arc, and reached its closest point, the Sun, on the exact side hidden from Earth, making it completely unobservable from the ground at the most energetically critical moment of its journey. The probability of all of that occurring by random chance is 0.05%, 0.005%. When Loeb saw that trajectory, he went directly to policymakers and urged them to prepare contingency plans for a black swan event, not because he had proof, because 15 anomalies compounding against each other produce a number that responsible people cannot walk away from. And then came Jupiter. On March 16, 26, 3i Atlas made its Jupiter flyby. The distance at which it passed was 445 million kilometers. Jupiter's Hill radius, the precise gravitational boundary where Jupiter's gravity dominates over the Sun's, and where an object can be placed into stable, long-term orbit using the minimum possible fuel, is 53.502 million kilometers. The margin between those two numbers is smaller than the distance from Earth to the Moon. Out of every possible distance at which a passing object could approach Jupiter, it approached at the one distance that represents the perfect deployment threshold, the exact location where, if you were a spacecraft on a mission and needed to leave something behind without burning excess fuel, you would stop. Loeb laid out the implication in published writing. This coincidence might mean that 3i Atlas released technological devices into stable orbit around Jupiter, at the Lagrange points where the gravitational geometry creates natural parking positions that require almost no energy to maintain indefinitely. And while that flyby was happening, at the single most important moment of this object's entire passage through our solar system, humanity's only active spacecraft near Jupiter was Juno, critically low on fuel, unable to redirect. The one moment we needed eyes at Jupiter, we had none. After the encounter, 3i Atlas began leaving, accelerating back into interstellar space at 58 kilometers per second on a hyperbolic trajectory it will never return from. The sunward jet kept going as it left. The deuterium kept venting. The anomalies did not resolve. They just moved further away until the telescopes could no longer track them. Loeb said it without hedging. Even if the explanation that 3i Atlas is a technological object turns out to be wrong, we must take it seriously because of what it would mean if it is right. 15 independent anomalies, each statistically improbable on its own, compounding across every instrument pointed at this object. The coincidences have run out. The age is wrong. The deuterium is wrong. The chemistry is wrong. The mass is wrong. The trajectory is wrong. The sunward jet is wrong. The Jupiter distance is wrong. Every measurement, every instrument. Every data point came back the same way. This object does not conform to any natural model we have, and the gap is not narrowing. 3i Atlas is gone now, accelerating toward the galactic center, carrying its answers into a void no spacecraft we could build would ever reach. But if something was left behind at Jupiter's Hill radius during that precisely calculated flyby, it is still there right now, in a stable position in the Jovian system, silent, patient, pointed at a small blue planet 600 million kilometers away, watching what we do next. NASA found something strange inside 3I Atlas. The question nobody is answering publicly is whether the strange thing they found was ever really inside it, or whether it was always the whole point.